For decades, digital marketing operated on rigid automation workflows, static decision trees managed by human operators. But as data outpaces human analysis, these legacy structures are transitioning toward agentic artificial intelligence, networks capable of independent reasoning and multi-step execution. The traditional optimization philosophy across the web has always been identical: ruthlessly minimize user friction to facilitate immediate action. This frictionless environment intentionally targets what cognitive psychology defines as System 1 processing. This is our pattern recognition reflex, a fast, automatic, unconscious state that relies on heuristics and high-arousal impulses to navigate information effortlessly. While selling a low-cost consumer good thrives on reflexive clicks, but converting high-ticket digital products or navigating complex network marketing commitments operates under an entirely different constraint. These transactions demand deep cognitive elaboration, sustained attention, and the rationalization of complex value propositions. Because a $5,000 or $10,000 commitment requires analytical evaluation, forcing these users through a frictionless System 1 sales funnel strips away the requisite value justification. Optimizing exclusively for speed actively destroys the probability of high-ticket conversion. To architect an autonomous system that actually secures these high-stakes conversions, digital marketers are integrating the Elaboration likelihood model, or ELM. The ELM identifies two distinct pathways for human persuasion. The peripheral route perfectly mirrors System 1. Users here don't evaluate the core merit of a product. They are swayed by superficial aesthetics, emotional valence, and technological realism, like highly polished AI-generated imagery, resulting in attitude shifts that are incredibly fragile and temporary. The central route requires high cognitive effort. When operating in this state, individuals meticulously evaluate information, retrieve relevant knowledge from memory, and synthesize reasoned judgments. Persuasion achieved through this central route yields attitudes that are profoundly more enduring and strongly predictive of long-term behavior. Modern recommender systems and complex social algorithms are almost exclusively trained to capture and exploit the peripheral route. They analyze rapid scrolling and passive lingering to feed intuitive impulses, leaving the underlying architecture incapable of fostering the deliberate, central processing necessary for major financial trust. Autonomous marketing networks solve this by doing the opposite of traditional web design. These agents mathematically detect a user's reliance on superficial scanning in real time and programmatically inject structural anomalies into the interface to force them off the peripheral path and onto the central route. In high-stakes digital environments, cognitive friction is no longer considered a user experience flaw. It is a programmed necessity to secure a sale. The mechanics of when to inject this friction are governed by information foraging theory. This biological model treats human digital behavior identically to how animals forage for food in an ecosystem. Users attempt to maximize their rate of gaining valuable data relative to their interaction cost. They navigate complex spaces using information scent, an imperfect estimate of value based on proximal cues like link labels, images, and headlines. As a user explores a digital patch, such as a landing page or an interactive network, they consume the readily available heuristic cues. Quickly, the rate of novel, valuable information extraction precipitously drops. The patch depletes. This graph tracks the AI calculating the information gain rate. The descending gray line shows effortless System 1 consumption. It decays toward the red dotted limit of abandonment. Agents isolate this intersection at time equals 5. At this millisecond, the visual metaphor injection triggers a sharp upward trajectory on the blue System 2 curve, renewing engagement. Biological attention decay has been transformed from an unpredictable human variable into a calculable, interceptable metric. Executing a mid-session intervention based on millisecond fluctuations is impossible on legacy infrastructure. Traditional REST APIs utilize stateless request-response communication cycles. Their inherent latency creates bottlenecks incapable of supporting bidirectional behavioral modulation. This diagram demonstrates the infrastructural replacement required to bypass latency. The critical component is the continuous double-arrow WebSocket connection bridging the client and serverless environment. Looking at the trace data extraction cluster, this architecture allows the AI to stream interface adjustments token by token without requiring a viewport refresh. The system continuously monitors micro-behavioral trace data. It extracts specific viewport fixations, scroll velocities, and precise click patterns directly from the browser. These physical movements correlate directly with cognitive states. High scroll velocities, erratic mouse movements, and rapid context switching explicitly indicate a reliance on superficial System 1 scanning and a rapidly depleting information sent. Returning to the system diagram, this telemetry streams directly into the isolated cloud environment. Here, specialized digital workers calculate the information gain rate and pass it through a strict threshold decision gate in milliseconds. By merging persistent WebSocket connections with micro-behavioral telemetry, the digital interface ceases to be a static document. It acts as a perceptive participant, reacting to cognitive states in real time. The exact moment the perception agent detects the information gain rate falling below the critical threshold, it signals an orchestration agent to override the standard user interface sequence. Deploying standard dynamic video or explicit text blocks fails at this stage. Simple aesthetic juxtapositions have zero cognitive friction. They allow the user to easily process the layout via heuristics and continue their rapid scroll toward abandonment. To actually command central root attention, the autonomous agent leverages conceptual integration networks to generate and deploy highly complex visual metaphors. The AI utilizes a mechanism called fusion replacement. A target object on the page is partially replaced by a source object possessing contradictory visual attributes. This creates a profound structural paradox that actively violates the visual expectations of System 1. The pipeline initiates with a perception agent, decomposing the prompt into a source, target, and meaning mapping. A generation agent then executes high-fidelity synthesis via diffusion networks. It binds the source to the target, creating a visually coherent blended space. Before deployment, a hierarchical diagnostic agent mimics a professional critic. It performs closed-loop backtracking to identify errors in abstract logic or component selection, ensuring the meaning alignment is flawless. This diagram shows the final step. Once validated, the system triggers the visual metaphor transfer injection, pushing the newly generated paradox directly into the user's viewport via WebSockets, right in the middle of their scroll. The user is confronted with an anomaly. To comprehend the message, they are strictly required to decode the implications of the metaphor. This required effort acts as a cognitive speed bump, terminating the rapid System 1 heuristic loop and finally elevating the user into deep, deliberate System 2 evaluation. In high-ticket environments, the bridge between an initial lead and a financial commitment has traditionally been one of the most resource-intensive stages of sales. While webinars and email sequences handle general education, the specific research, lead classification, and personalized outreach required to close five-figure contracts have historically served as a significant human-centric bottleneck. Early chatbots failed to solve this because they functioned as disjointed autoresponders that suffered from memory fragmentation across disparate channels. Modern AI agents solve this by maintaining continuous, persistent cross-session memory, utilizing queryable, durable objects. At the enterprise scale, these systems are deployed as AI swarms. Thousands of autonomous personas operate in parallel across decentralized network marketing downlines, adapting narratives and analyzing behavioral trace data simultaneously. These swarms leverage generative engine optimization to dominate discovery. When a prospect inevitably leaves a page to seek third-party validation, the swarm has already seamlessly orchestrated AI-generated proof points across the web to reinforce the narrative. Rather than relying on human marketers to review static split test data at the end of a quarter, diagnostic agents evaluate thousands of generated visual metaphors in real time. They aggressively phase out low-performing creatives and instantly scale the specific permutations that successfully trigger System 2 processing. By merging cognitive mathematics with continuous agent swarms, organizations replace fragmented, easily fatigued human labor with a relentless, hyper-personalized engine of high-ticket persuasion. The deployment of real-time behavioral modulation creates a complete asymmetry in persuasive capability between algorithmic swarms and human consumers. Historically, persuasion was a somewhat symmetrical dialogue, where consumers could recognize a sales tactic and raise their cognitive defenses. calculating a user's exact millisecond of cognitive exhaustion and injecting heuristically targeted stimuli bypasses those conscious defense mechanisms. Beyond ethical exploitation, these systems introduce severe security vulnerabilities. Sophisticated jailbreaking attacks can force an agent out of alignment with its core directives, weaponizing real-time visual rhetoric to execute domain-specific harms, bypass regulatory compliance, or manipulate financial transactions. Defending an autonomous marketing swarm requires embedding strict structural constraints directly into the architecture. Platform engineering teams mandate direct preference optimization and curate highly restricted institutional skill libraries to prevent agents from violating organizational norms. Managing this technology requires distinct regulatory imperatives. This includes mandated transparency watermarks for all synthetically generated visual media and enforceable hard limits on the depth of biometric telemetry tracking permitted for cognitive profiling. The algorithmic induction of cognitive elaboration provides unprecedented efficacy for digital commerce, but wielding decentralized, automated persuasion without robust structural governance risks devolving the digital economy into an environment of undetectable programmatic coercion.